Hello guys, welcome back to my channel again. I am back with another series of doing late code till I get a job. Few updates I want to share. I'm being late as you can see after a lot of days I have uploaded this video. Sorry for being late. If you are just wanna like do the solving, you can skip this part and I will just put the timestamp in the comments. The updates I want to share is I was having an interview in Amazon, so I was preparing for it and I had that interview, so that's why I couldn't upload during that time. Um, and that's all. I will let you guys know what happened in the interview. If you want, I can just share another video of it. If you guys want, please comment, like, and share, subscribe, and do all those things. I'm not doing these videos for like comments or subscribers. Currently, I don't know what I'm gonna do. That's why I'm doing these videos. So please let me know if you want that Amazon interview experience. I will share those. So that's it, I guess. So let's start this coding. What is the problem today? I was last doing this problem, remove elements. I'm gonna do this one, remove duplicates from sorted array. This is the third question of our series. So here is the question, the problem. What is given is, if you can see over here properly, what if you can see over here properly is, there is given a array, which is like this array. Okay. So we have to remove the duplicates and get the non-duplicate elements in the front, right? So if you can see here, this is 0, this is 0 also, so there are duplicates element, and this is 1, which is non-duplicate element. We have to remove this non-duplicate elements and remove this 1 and get this 0 back, right? Get this 0, get the 1 in front, get this 1 in front, right? In front, like over here. Same for after this one, it will be like 0, which will then there will be 1, then there will be 2, because the non-duplicate element next is 2, then there will be 3, then there will be 4. So this will be the output array, which will contain non-duplicate 5 elements, 1, 2, 3, 4, 5 elements, and we have to return the output, as well as we have to rearrange the array also. Your function should return k, which is 2 over here for this one, 1, 1, 2. We have to get the 2 in front, and we have to then change this whole thing, right? So if I look for the solution, what can we do over here? Okay, first of all, we can think of one solution, uh, which is like a brute force kind of solution, where what we'll do is we're gonna mm, uh, put this whole array into a list. I'm thinking of a list. Okay, list or a hash set. You can use a hash set or a list. Let's use a set. Okay, set will be great, I guess. Let's use a set. Yeah. So we are gonna put this whole list into a set. Let's create a set. Okay, so we're gonna iterate through this list one by one. We're gonna iterate through this list one by one. Yeah, so if we put this whole thing into the set, we will just get like iterate through this thing. Here first, if we see the, if you see this is the I. We can say this is the I, which will iterate through this thing. I will be here at first. We can start I from 0. Then if 0, I'm gonna put this 0 into the set. Now after this, I came to 1, which will also be 0, and this is a duplicate. So when we'll find the duplicate, we will gonna just change we are not gonna, if as set dot contains the duplicate, we will not gonna add it to the list or the set, whatever we will use. Right now, we're gonna change the I again. Now, if set dot contains this, we're gonna put it, or else we're gonna skip it. Okay. So this is the list or set approach. If I just write the code over here, we're gonna just for this is the algo we are using. I2, let's say I equals to 0, 2. We're gonna run it till the end of the array. Here are dot length, you can say. Right. Now what will gonna happen is Um, let's say we are using a list. Let's do list of integer. Okay, L. So what will gonna happen is we are gonna check for if this thing is already inside the list. If this thing already inside the list, we're gonna not put it over here, right? If let's check if list dot contains, this is the Java method. You can just check for your methods in like your language, appropriate language. There is no language boundary in this thing. List dot contains, let's do ARRI. List dot contains this. Then we're gonna ARRI, or if we are gonna for I just, then we're gonna check if list dot contains this. Then we're gonna not put it. If doesn't contains it, then we're gonna list dot put inside the um we're gonna put or add inside the uh, I I will be put it inside the list. But here the problem is where another thing comes for, we have to write another loop, or we have to iterate through the list, because we have to iterate through the list. Let's say list dot size. Okay, we have to iterate through this list again. Why? Because we have to return a array over here or an integer over here, and also we have to make the array, which is this array, into the like list according to the list, which will be like 0 1 2 3 4, right? We have to update this array again, so we have to run two loops over here and iterate through it. So here for that thing the time complexity for this problem will have like this problem will be like O of um n square, right? O of n square, the time complexity will be which is really not that good. Also, we have to use a list for this. This is not the time complexity for the, this is the times complexity for the brute force approach. And also we are using a list to contain, let's say, n elements into it. So the thing is the space complexity will also be O of n, which is not that much good of an approach. And if you are showing it inside an interview or something, that will be bad. So here, after this, we can just, let's say, change the approach. We have to make another better approach inside it, right? Let me just delete this thing, right? Um, yeah. So after that, what we can do, what is the appropriate approach for it? Here, the thing is, we have to look for one thing. The array is sorted over here, right? As you can see, the array is sorted 0 0 1 1 1 2 2 2. It is not an unsorted array, right? So um, what we can do is we can think of an sorted array, means the approach could be we can use a two pointers kind of approach, right? Two pointers kind of approach. What will be the two pointers kind of approach? We can just, let's say, this is the I which is iterating through, and this there can be another like pointer, let's say position pointer. Okay, this position pointer, this position pointer will be, let's say, looking for this position pointer will be, let's make it dark or more. Okay, this is the highest dark, I think. This position pointer will be pointing towards the position which is the duplicate one. Did you get it? This position pointer um will be the duplicate one, right? So what is this showing? Let's say I is going through this. I is, let's say, starting from 0 or 1. Okay, we're gonna check if I minus 1 equals to the I, means what? If, let's say, I equals to I minus 1, which will be nums of I know that. You have to like just go for the language according to it. I'm just solving it. So if I minus 1 equals to I, that means this thing and this thing are the same, right? This thing and this thing are the same. This and this both are same. So for that, we what we'll do is like we're gonna uh change the I again. like we're gonna iterate the I again. Here, look at this. Here, I, and this is the position pointer. We'll be first setting it on the like one. Let's set the position pointer in one equals to one, and check for if I equals to position minus one. Yeah, so position minus one. So here I, which is not equals to position minus one. What we're gonna do next is we are gonna, let's say position, here the position we're gonna change it with I, means we are gonna say, let's say position equals to I. What will gonna happen? This 0 will change to 1, and this 0 will change to 1, and we are gonna change the position to plus plus also, position to plus plus. So what will happen? This position will go from here to here, right? Here to here. Now after that, position is in 1, I is in 1. The loop will, let's say, I2, then like now the loop is gonna go from here to here, where I is 1, position minus 1, which is this, is also 1. So as the position minus 1 is also 1, then and nothing will gonna change. I will get again plus plus. If I get plus plus, then I would be over here again. Here also position minus 1 is 1, and this thing is also 1, right? So it will not gonna change again. After this I will be over here. Here I is not equals to position minus 1. Sorry, this will be I not equals to position minus 1. So I not equals to position minus 1. We're gonna change the position with I and do the position plus plus again over here, and this will be over here. Now again I will be plus plus over here. I is 2, which is position minus 1 is also 2. So the thing will not gonna change. Here I is 3, position minus 1 is 2. So we're gonna change the position with 3, and let's say this, let's say position will be plus plus, and position will be over here. Again, I will get plus plus over here. I minus position minus 1 is 3, I equals to 3, nothing will change. Again, I will be over here, position minus 1 is 3, I is 4. So position will change to 4, and position will be over here, plus plus. Now, what is happening? The I is at the end of the array, right? So we are gonna return what? We are gonna return this thing now. We are gonna return the position now, right? So I hope you get the whole thing about the position pointer and the overall approach. If I look at the code right now, you can, if you can see the code, what is happening? We are gonna check if nums.length equals to 0, means the array is 0 or not. If it is 0, then we're gonna return 0, as if there is empty array, there is nothing we can do. Then if we're gonna check for we are gonna run a loop over here, run a loop over here, run a loop which will gonna go from 1 to nums.length. Then we are checking for if nums I not is equals to nums of insert position minus 1. If it is not, then we're gonna put it, else we are not gonna put it, I plus plus will happen. So let's like see if this code runs or not. Right. Here is the whole code. You can see. Let's run it. and let's try to submit it. Okay, so as you can see, this is the approach overall. And if you see what is the like complexity over here, uh, time complexity is O of n, as we are just running through the loop once. That's why it is O of n. Um, and that's all. If you like this approach and things, thank you for watching and do whatever you want to do. Thank you.